Thank you for coming to this session. Can you hear me? Yeah. Because I can't really hear myself. Well, this is the famous after lunch session, which means that some of you, hopefully not all of you, will fall asleep, but that's okay. I will try my best to, keep you awake. First, before we start, I'd like to ask you, how many of you are using Git? So everyone, okay, that's good. How many of you are using it through a graphical user interface? Only. Ah, okay. And how many of you are using it through the command line? Wow. So that's like most of you. But there is someone who never raised their hand. So what are you using? Is that like some kind of voice control? That counts as command line, I'll say. All right, so that's good. So this session is about things that you can do with Git that you probably wouldn't know about if you were using a GUI. Before that, we are also going to talk about how Git actually works internally, because I believe that's the key to understand how to use it from the command line. Instead of just memorizing commands, if you really know what's going on internally, then you will remember them by heart. So that's what I'm going to do today. But first, let me tell you a little bit about myself. I work as a consultant in a relatively small consulting company called 1337. I'm based in Sweden, where 13 is the Swedish word for 13. So it's 1337. I know, I see some eyes rolling, yeah. I need to explain it every time because it's in Swedish and half number, half Swedish. Funny thing is that in Sweden, many people actually think this is some kind of taxi service. 1337, like call them and get a taxi. What do I do there? I work as a programmer. I'm guessing you guys are also programmers or involved in programming, right? How many of you are writing code? Okay, good. You are the right audience. Yeah, this is me when I was working from my home office. But it was a while ago, as you can see from my hair. But we're not here to talk about the good old times. We're here to talk about Git. So my journey with, I would say, distributed source control systems did not start with Git. Instead, it started with something else called Mercurial. Have you guys heard about Mercurial? Few of them? Okay. Some of you. Mercurial is a distributed source control system like Git. That is, you have both the server and the client on your machine, and you don't have to connect to a central server like you would, for example, with Subversion. And the thing with Mercurial was that it was said to be Windows friendly, whatever that means. Well, the executable ended with .exe. Maybe that was what was friendly about it. But there were some issues with Mercurial, which we're going to talk about. So, after a few years of Mercurial, I felt that there had to be something better, and that turned out to be Git. And when I started using Git, I never looked back. So basically, Mercurial, I don't even know if Mercurial exists anymore. It doesn't really matter. So, what's different about Git compared to Mercurial? Well, Git does a few things differently. And the first one is how it views history. Now, let's all agree on one premise. If you want to study the past, well, if you want to go ahead, you need to understand how you got there in the first place. So the history of your source code is very important, right? Can we agree on that? So that means we need to take care of it for the future generations. However, source control systems historically have been very unforgiving when it comes to history, because once you commit something, it's there, it's final. You sent it to the server, you cannot take it back. And the problem with that is, we make mistakes, and we don't really like to pollute our history with all the mistakes that we make while we work. classic example, now you push some changes and then you forgot one file, which should have been part of that commit. So what do you do then? You do the so-called apology commit, where you say, sorry, I forgot. It's almost like sending an email where you say, find the attached document, but there is no attached document. Then you send another email, yeah, by the way, here is the document. So this happened all the time with source control system. However, Git has a different view, because with Git, you don't have to pay attention that much about the history of your code while you're working. Instead, you pay attention to it when you're ready to share it. Because the history of your source code is not the same thing as your own personal workflow. So you should be able to work the way you like without caring too much about how the history of your code looks like, how many commits you make, what the messages are. However, once you're ready to share those commits with the rest of the team, that's the point where you take care of your history. So the history is public, however, your workflow is private. Or as Linus Torvalds said, very eloquently, don't expose your crap. Don't make crap commits that, well, make them, but keep them to yourself. Never share them with anyone else. Now, the second thing that Git does differently, apart from the way it views history, is the way it views branching. Now, if you've ever used a source control system that has branches, how many of you have used that, which is not Git? Like, for example, TFS, Subversion, yeah. So you know that the golden rule of branching was you never do branches unless you absolutely must. Well, in Git it's different, because branches are not this expensive operation, this entire copy of everything, all your files that you need to manage, like it is in other source control systems. In Git, branches are cheap. It's a cheap operation, as I'll show you later. Actually creating, I won't tell you now, I'll tell you later. So branches are cheap, just take my word for it now. And when they are cheap, you can make them useful. You can use them as part of your workflow. So now you can create branches that are actually meaningful to you. You can take advantage of the fact that Git has cheap branches. So remember the rule about never ever doing branches unless you absolutely have to. The new rule is branch like there is no tomorrow. Branch every time you like. No, create branches for a bug fix, for a feature, create a branch for an experiment, and then throw it away if you don't want it. And then you can also have branches that are shared with the team, like work for the next version, release branch, whatever. Okay. So history and branching are two fundamentally different views of the world that Git has compared to all the other source control systems that exist. But, you know, so this sounds very good. However, there is a problem. Git is kind of hard. How many of you here think that Git is hard? It has a steep learning curve. All right, so, okay, about maybe 1/4. So I'm guessing that the rest of you think it's easy. So that means that I missed my mark, because I wrote almost everyone, which is usually the case, but you guys must be very experienced. And I didn't have time to change it now, so let's say this should actually be 1/4 in this case. Anyway, Git is hard. And it's in fact, actually, that's so hard that, I don't know if you noticed, but people like to complain on social media. And they take to social media and they write things like this. Git to me is harder than programming. Now, this is a bold statement, but I understand. I would probably say it like this. Git is not harder than programming. Git is about as hard as programming. Because as I'll show you later, Git can be seen as a programming language. And that's actually the best way to think about it. So what happens when something is hard in computer science? What do you do to deal with the complexity? You build an abstraction, exactly. No problem can't be solved by adding another layer of abstraction. And in the case of Git, the abstraction took this shape, the shape of the GUIs. So people dealt with this complexity by building the, I know you're not supposed to read the text. However, I don't know about you, but how is this menu and this right-click menu easier to use than using the command line? I don't know. This whole thing makes me kind of sad. So, if you think that Git is hard and you are trying to use one of those GUIs to kind of help you, let me tell you this. What if I told you that Git is not hard? In fact, it's very easy. And I'll show you how. So, let's do a little experiment. Can you see this kind of? This is a regular Explorer window. I wish I could zoom in. Let me see if I can zoom in. No? Well, doesn't matter. Can you kind of see all the way from the back? Yeah? I know. But this is gonna be quick. We are gonna do a little project together in a world where Git doesn't exist. Actually, let me see if I can zoom in. Can I do this? Oh, well. That didn't really help. Whoa. No, this is not good. Well, let's all agree that we keep it like this. So the only thing we have is the file system. We don't have Git. We actually don't have any source control at all. So we are working on a project, okay? So what do you want to call this project? Do you have a name? Suggestion? That needs to be like an acronym. Are you sorry? YOLO? Oh, well, yeah. That could be. I was thinking something about, like, for example, the Windows. I am assuming you're developing on Windows. Yes or no? No. Not at all. Ah, this will be even funnier then. Okay, so in .NET and the Microsoft frameworks, we had something like the Windows Presentation Foundation for the GUI and the Windows Communication Foundation for doing distributed systems, and we had the Windows Workflow Foundation, to do workflows, but we never had something called the Windows Testing Foundation. We never had that. So what about we do it? We do the Windows Testing Foundation, and of course we should call it by its acronym, which is WTF. Can you kind of read that? Well, no, but you know what it says. Well, actually, let me give you one more shot at what if I do the zoom control, turn magnifier on. Wow, magnifier on. Does it help? No, I give up. I officially give up. Okay, so we have this file. It's a text file, and we do some work on it. At some point, we need to record a snapshot of it. All right. So what do? Well, you create a directory, and we name the directory with a message that describes the state of our files right now. Okay. So for example, let's just call it with the letter A. So this, and then we take a copy of this file and we paste it into that directory. Now we keep working on it and we make new copies as we progress, correct? So let's make 3 of them. So now we have 3 snapshots of our project at 3 different points in time, and here there are supposed to be dates. So it's the timestamp on when it happened. And that's all fine and dandy. Then we release it. So let's say that this, the third snapshot, is where we release it. And then we keep working on it. So we make another one. This won't go for too long, so don't worry. We make a copy that contains the work for the next version. But now someone reports a bug in the released version. So what do we do? Fortunately, the snapshot before contained the version as it was released. So it doesn't have the new changes. So if we want to fix the bug, we can go into that one, take the file from there. Oh, this was big. And then replace it with the copy that we are working on, our working copy. So now we have the version of the file as it was when it was released, so we can fix the bug and create a new, let's call it E. All right. However, we have a problem now. So we have a sequence of snapshots that look like they all appeared in sequence. However, we know that after the release, we had two different snapshots. One that contained the bug fix, and one that contained work for the next version. But we can't see that just by looking at this sequence of directories. So we need a way to somehow reconstruct this history of commits, of snapshots. So if you only have files and directories, what do you do? Any ideas? Sorry?
C2.
Well, okay, so you include it in the directory name, for example. So one way to solve this is to, how about we, in the name of the directory, we include the name of the directory that came before it, so the previous snapshot. So for example, with A there is nothing. With B, we would say that A is the snapshot that came before B. So we write A-B, I know you can't read it. Then we write B-C. And at C, now we have two snapshots that derive from C. We have C-D and C-E. So now we can reconstruct, by following the parent directory, we can reconstruct the history of the snapshots, even if they are not sequential, just by recording what snapshot came before it. Okay, this is a pretty powerful concept. However, we have another problem. We are always going to work with the latest snapshot in a line of history. So it would be nice if we could somehow name it in a way that we can remember what kind of work we are doing into this line of history. So we only have files and directories. What do we do then? We're always going to work with the latest snapshot in a line. So what about we create a text file? We call it branches.txt. And in this file, we simply associate a name with the latest snapshot in the line of history. So for example, if we have two lines right now, the released line and the next version line, what do you want to call them? For example, for the next version, we should maybe call it vnext. And then we say that the latest snapshot in vnext is D. And for the main line of history, the one that's released, let's call it, for example, master. And we say that the latest snapshot in master is the one with the bug fix, that is E. Correct? So now we have a name associated to the latest snapshot in a line of history. And from there we can follow the chain of parents to reconstruct how the history went. And this is just by having files and directories. However, we have another problem. Can you see what the problem is right now? If you consider our working our working copy, the file that we work on all the time, can you tell from which snapshot that file is coming from? No, right now we can't tell. It must come from a snapshot originally before we modify it, but we have no way to know from which. So how about we create another text file, and this time let's call it head.txt, and in this file, remember we're always going to work in a branch, so how about we record the branch we are currently working on. So for example, master. So by looking at the head reference, we can see that we are working in the master branch, and the master branch is going to point to a snapshot, and from the snapshot we can follow the chain of parents. Now what I've shown you here is what Git does under the covers as you are working with it with all the different commands. So Git is actually nothing more than a bunch of snapshots of all the files and all the directories in your working directory, in your working copy. And these snapshots are managed by a domain-specific language, which are the commands that you work with from the command line. That's why I said before it is best to think about Git as a programming language, because that's what it actually is. It's a domain-specific programming language designed to manipulate all those snapshots of your files and this structure of branches and references. So there you have Git. It's almost like if you had a time machine. However, a time machine, you might prefer another time machine, like for example a telephone kiosk. I don't know. I like this time machine. However, the time machine of Git can only go backwards. Can't go forward. And on top of it, you apply a nice command line based programming language, and there you have Git. So imagine those two things. It's like chocolate and peanut butter. So let's revisit this concept. We said that Git is hard, and yes, I agree, but the syntax of Git is hard. This domain-specific language that you interact with is hard. And I'm sorry to say that it's hard for no good reason. There is no reason why Git has to be that complicated. The reason is that Git is made by programmers. Yes, and many programmers. And you know what happens? You know, they say if you have too many chefs, they will spoil the soup. Now imagine if you have too many programmers in the kitchen, they won't get anything done. They will start arguing about the different kinds of breads, different kinds of butters and cheeses and stuff like that. So they will never get anything done. In the case of Git, you just put everything on top of each other. You just stack stuff as you come with new ideas. So yeah, the syntax is hard for no good reason, and I'm sorry, I apologize for the programmers who contributed to Git. However, the concept, as I showed you, is very trivial, is simple. So let's revisit it. There are only a few concepts to remember when you work with Git. There is the commit, and the commit contains the metadata about your change. For example, who made it, when, and email addresses. And another important thing that the commit references is an object called a tree. And a tree is basically Git's own abstraction on top of a directory. So the way it represents directories internally is called trees. And trees can have other trees underneath them, or they can have blobs, which are the actual files. Now remember that Git basically only tracks the files and the path of the directories where they are located. Now, this stuff is referenced by a commit, and a commit has another important reference, which is the reference to the parent. And the only thing it references is the parent, which of course also has a tree or more trees and one or more files or blobs. On top of this, we have defined a concept, which is the concept of a reference or a branch or a tag. Those are named references, which are only files, text files, that point to a specific commit. And I see that you don't believe me, so I'm going to show it to you. So let's go back to the demo. Now let's see if I can. So how is the font this time? Is it okay? Too small? No, for real? Okay. Then I can make it bigger. Let me first spend a few minutes to align it perfectly. Okay. So let's make this. Ooh, that was big. So let's make it like 40, 45. Not enough. 55. And then let's bump this up to 30. Nope. 30. What about this? Is it better? Is it more? It's all right. You need to make up your mind. Is it okay or no? Yep. All right. So it's very important that you can read this text. However, it's going to be lighter. So what I have here is that I have a command line prompt, which in this case happens to be PowerShell, but it could be Bash or Z shell. By the way, what kind of command shell do you use? So how many of you use Bash? Okay, so half. How many of you use Z shell? Okay, few. And how about the new one, Fish? Even fewer. That's why it's new. And then PowerShell? Okay, few. All right, so the majority I would say use Bash. So you know about it, you can have those plugins in Bash to show you the name of the branch you're on, stuff like that. There are also similar plugins for PowerShell. What I have here underneath is a graphical representation of my repository. So each one of those boxes is a commit. And this is similar to the graph I showed you. The thing with this software is that as I work in my, so they point to the same directory, both of them. As I manipulate my history up here, this will refresh to show you how it actually looks like visually. Okay? However, this program that I use here is very, unstable. So I might have to, actually I will have to quit it and reopen it at some point because the graph gets all screwed up. And if we're really unlucky, I might have to reboot my machine. But let's hope not. Let's hope not. So now I told you. So I told you that the branches are references. So let's look at them. There is a low-level command in Git that you never ever interact with called showref. Showref will show you all the references that exist in your repository. Remember, branches are among them. And right now we only have one. It's called master, and it contains this long string over here. Now what this is, I bet you already know it, but I'll tell you anyway, is the SHA1 hash of the commit that it points to. Okay? Because in Git, the way Git uniquely identifies those objects that I showed you, commits, trees, and blobs, the way it can identify them uniquely is by making a hash of their contents, and the hash becomes the ID. And the advantage of doing this is that those IDs are unique across machines. So it doesn't really matter which machine you're on, the same object, the same commit will have the same ID, which is very important since Git is distributed. So it's not dependent on clocks or stuff like that. So let's take a look at this. So I'll copy a portion of this hash Doesn't have to be everything. Enough it to be unique. And then I will use another low-level command, which is called cat file. Remember, the Git has been built in layers. So initially, Git basically consisted of 4 C programs that manipulated the structure that I showed you before. Those were written by Linus Torvalds. And once he did that, he basically said, I'm done. No, now it's good enough for me. And he basically handed it over to the community, which then is responsible for building all the other things on top of those commands. So Git, all the commands in Git have always 2 layers. There are the commands that you normally interact with at the highest level, and those make it so that Git looks like a source control system. So it behaves as a source control system. And then there are the lower level commands, which are these, which manipulate the low level structures. The low level ones are called plumbing, and the high level ones are called parceling. So if you see those words, parceling command versus a plumbing command, it means that parceling is the user level commands and plumbing are the lower level commands. Now, cat file is a lower level command, so it basically just prints the content of an object. So let's give it this ID. And what do we get back? Let's take a look. Oops. So we have, as you see here, a tree object. The colors are horrible. Then you have a parent, which also is an ID. And then you have the author information. Okay? So you see, this is the content of a commit. The hash of all those values together become the commit ID. So if you remember, that, which we're going to look later, that if you modify anything about a commit, for example, the timestamp when it was made, it changes the ID. Which means if other people have that same commit on their machine with a certain ID, if you change any of those fields, the commit will get a new ID. And Git will think that it's a different one. Even if you only, for example, change the email address of the author. So let's take a look at the tree. We copy a bit of this ID again. And let's use a different command that's called ls3. Recursive. Let's paste that. And look what we get. We get the files that are in my repository. You recognize the WTF framework. And you see those are called blobs. These are the actual files in the snapshot referenced by the commit. Now let's grab one of those files. Well, the ID. This, of course, is the hash of the contents of the file. And let's use the cat file again on that. And we'll look what we get. We get, this is C#, it doesn't really matter the language. You see, this is the entire file. It's not a diff. This is super important because other source control systems, when you commit something, they just recorded what was different from the previous version of the file. They recorded the so-called delta chain. In Git, it's an entire copy every time. But now you start thinking, wait a minute, if every commit is an entire copy of everything, then I'm out of space. And it's true that it's an entire copy, but then Git is smart in the storage level, and it won't actually store everything. Since it has snapshots for every commit, Git is able to say, okay, given these 100 commits, let me calculate the final diff and store only that, plus some references to be able to reconstruct it later. So, but this is just a storage detail, an implementation detail. It doesn't, conceptually, it's, as you can see, every commit contains an entire copy. So if I, for example, use now a high-level command, the show command, which means show me the diff of the commit that I that is referenced by master, you see that it's calculating the diff. But the diff is calculated on the fly. Okay? So, hopefully now you believe me. Yes? Still no? Okay, I'll show you one more thing. Let's open, every Git repository has a .git directory, which is hidden because it starts with a dot. And if we open it with the file system explorer, okay, it's worthless. Basically, these files, if you could see them, you will recognize that there is a file called head and a directory called refs. Well, maybe let me do this. Since we have a command line, I can do this. So git, there is a file called head. Well, which has this content. You see, the file called head just contains the reference to the branch that I'm currently have checked out. And then if I do the same thing on that, git refs heads master, then I have that. And this is a 40-character string, so therefore a branch is a 40-byte file. So when you say new branch, you're creating a 40-byte file. My head exploded the first time I realized this. So let's do a few things that are actually useful with Git. So I guess that when you look at the history of Git, maybe you do git log, yes? And then git log maybe looks like this, like that. What do you think of this? It's okay? No, it's not okay. I'm happy to hear that, because one of the funny thing about git log is that you can choose to view history any way you like. Well, almost. So for example, if you don't like to scroll all the text every time, you can, for example, say log one line and get a more compressed version of the history. You see, A, B, C are those. Okay? However, we can get even fancier. Much, much fancier than this. Turns out that the log has an option called pretty. And now this starts to get really weird. But if you follow me, you'll understand this. So we change the color of the foreground, well, of the text. For example, let's make it red. And then, for every piece of information in the log, there is a corresponding placeholder. And these are documented, of course, on the Git website. So for every small piece of information, like for example the commit hash, the author, the timestamp, there are specific placeholders which you can use in this string to compose your output. So for example, now we change the color to red, and we want to just print the abbreviated version of the hash. That means the first 6 or 7 characters, which is %h. Then we reset the color. We do a space, now we put a pipe sign because it looks good. Then we change the color again, and this time we say that it's yellow. Then we want to print the references that are currently pointing to a commit. So if there is a branch that points to a commit, we want to see the name of the branch. If there is a tag, we want to see the tag. Now, what would you guess the name of the placeholder is for the references? Refs? Yeah, those are very good suggestions. Actually, I would expect it too, but no. Unfortunately, the placeholder is D. And you see where it starts to get, why? There is no good reason, because references doesn't have a D. Well, I guess that it was already occupied by something else. So, %c yellow, then let's reset the color again. Then let's print the commit message. Now you will expect it to be M maybe, but by now you should know that it's not. So the commit message in Git, actually there is a convention for how you write your commit messages. And if you have browsed, for example, the Git repository on GitHub, you will see that all commits have a short sentence, and then if you expand it, you see maybe a paragraph of text underneath. And this is a convention. So good commit messages start with one sentence, which is at the most 50 characters. And if you want to write more, you make a new line, and then you write how much text as you want. So the first line is called the summary, and the rest is called the body. So if you just want to see the summary, you say %s. Then we change the color again, and we make it green, for example. And then we make a parenthesis, because it looks good. And now we want to print out the commit timestamp, so the timestamp when the change was committed. However, we don't want to have the absolute timestamp. We want it to be relative to now. So we say CR. Okay? And then we finally reset the color again. So let's see. Nice. See how beautiful this is now? And I mean, see, now I went slowly, but I mean, I'm pretty fast at typing this string. I type it many times a day. Every time I want to look at the history. Now, of course, you won't do that.
Welcome on the stage, Mr.
I'm already here. Thanks. So what do you do? Turns out that there is a feature in Git called aliases. Do you know about aliases? Yeah. Okay. So of course, but maybe what you might not know is that aliases can contain any combination of commands and options. Did you know that also? Okay. And what you might not know is that aliases can actually contain shell functions that take parameters. How many of you knew that? Okay, a few. All right. So aliases can be literally anything. In this case, it's just a combination of log plus an option. So we say alias, and then we say, we say config, sorry. Then we say alias dot, and then since log is already occupied, we're gonna say lg, okay? And then we basically convert everything into a string. Of course, you don't have to say git again if it's an alias. If it's a shell function, yes, you need to do that. So you basically say add this alias called lg and associate it with all that string. And now you can say git lg. Pretty nice. Okay? So I'm gonna use this for the rest of the demo because it looks much better. All right. So what else can you do? Now we said that with Git, it allows you to take care of your history before you share it. But while you work on something, you're free to do as many commits as you like. Now let's open up our file and make a few changes. Of course, I'm using the editor. How many of you here are using Vim? Few? How many of you are using it voluntarily? Like, okay, slightly less. Now, I don't know if you noticed, but there has been recently an anniversary on Stack Overflow. The question of how do I exit Git reached 1 million views. And the people at Stack Overflow, who apparently have a lot of time on their hands, they decided to make some statistics. And they calculated how long the question has been on the site, and the total number of views, and the total number of upvotes. And they basically arrived at the conclusion that worldwide, someone needs help exiting Vim every 10 minutes. Isn't that amazing? And then they did some statistics about what kind of users, people who had an account and are active on tags, both questions and answer. They made statistics. So who are these people that need help? And they arrived to the conclusion that it's mostly people who opened Vim, who got surprised that Vim showed up. They did not start it. Did not mean to start it. So, for example, tags like jQuery and CSS, so front-end development, probably they did not mean to open Vim because they have other editors. However, C programmers and Perl, those have the lowest ratio of how to do I exit Vim, because if they open Vim, hopefully they meant it, so they know how to exit. So that's pretty interesting stats. Fortunately, I know how to exit Vim. So here is the program we have. If you do Java, anyone here doing Java? So that's what you are doing. And what about, how many of you are here doing the script version of Java? JavaScript. How many? A few, all right. Okay, I was joking. I know. Actually, there is a way to remember it, which I use myself to know the difference, is that I think like this. Java is to JavaScript what car is to carpet. So then I remember it. Okay, so I have this file. Let's make two meaningful changes. Let's remove the static over here. And let's, actually, let me go all the way to the bottom. And here, let me add a comment, like, for example, do something with the args. So now I have made two changes, right? I removed a keyword here, and I've added a comment here, all right? So those two changes, I made them at the same time. However, actually, let me exit it. I made those changes at the same time, but they are not related. One change is an actual modification of the program, and the other one is a comment. So they don't make sense to have them in the same commit. They are totally unrelated. However, if this was another source control system, we will have no choice. And either you make the changes one at a time, so first you do one change and you commit, and then you make the other change and commit, or you make everything in one. Now, this is a trivial example, but imagine if you are, for example, fixing a bug, and while you're fixing the bug, you discover that a function has the wrong name. So what do? You're working, so I renamed the function. And that function maybe had 100 references, so then your bug fix, which was supposed to be one file, has 101 files, because you also renamed the function. Now, it would be nice if you committed the bug fix by itself with an explanation of what it is, and the rename separately. However, you don't want to have that in mind all the time. I need to do one thing at a time, otherwise I'm gonna screw up the history. You want to be able to free yourself. So, in this case, in Git, before you commit something, you need to add it to this magical place called the staging area. Do you guys know about the staging area? The index staging area? Yeah. So a little bit of history about this. Actually, the staging area, or the index, was not meant to be used as we are using it today. The index contains a copy of all the files as they are in the latest commit. So remember that Git only saves, storage-wise, only saves the differences over a sequence of commits to be efficient. Turns out that what you want to know pretty often is that what changes have I made in my working directory that are not in the latest commit. So what differences do I have that are uncommitted? That's something you want to do very often. And if Git has to dig up the commit changes from the storage files, which are called pack files, all the time, it's not a waste. So what they implemented early on was that we need a way to make quick comparisons between what we have in the working directory and what's in the latest commit. So that's why they created the index, which is a cached copy of the files and the path in the working directory as they were in the latest commit. So the index was an optimization to speed up the comparisons. However, since the index contains what's in the latest commit, it turns out that it's pretty useful to be able to decide what's in the index and what's not. It's pretty useful to, given all the changes that you have, to be able to say in the next commit I only want this file, not everything I've changed. So the index turned out to be a pretty useful feature. It started out as an implementation, an optimization, but then it became a user level concept. And that's why, and there is an interesting, if you Google for it, there is the whole discussion of what should we call this. We can't call it the index because people won't understand how to use it. So then they came to the conclusion that let's call it the staging area, because what you are doing is that you are staging your next commit. You are deciding what's going to be part of it. Amazing stuff. So the index exists. I call it the index. You can call it staging area. And the command to add something to the index is add. And you will usually maybe add the file like this. What you might not know is that you can also add a portion of a file to the index by specifying patch or p. Now all commands in Git either have the long version with 2 dashes and a word, or 1 dash and a letter. Now Git opens up an editor with your changes, and look at this. Now first let's spend a few minutes to talk about this. Now the first time I saw this word, I could not, no, it's not what you think it means. It doesn't have anything to do with good looking men. However, every time I do this, I cannot get the picture out of my head. So this hunk, basically, it's a terminology that comes from the universal diff format, which is a real thing. It's also on Wikipedia. It means just a portion of a patch. So a set of lines that are close together in a file that are modified. So then you see the word stage. So do you want to stage this hunk? And then Git gives you, which one do you want? And you see why this is not. There is no good reason. Let's suffice to say that you can either say yes, I want to stage this entire hunk, or no, in which case I go to the next if there is a next, otherwise I just exit. Or if in this case I want to commit them separately, then I do split S. And then Git says, okay, I split it. Do you want to stage this one? Now it's showing me the first part, the one where I removed the static. And in this case I say, yes, I want to stage this. What about the comment? You want to stage that? No. And now I'm in an interesting situation where if I do git status, I have the file which is simultaneously in the index and not. And now your question begs for the question, how do I know what I've staged and what have I not staged? Where if you want to know what you staged, you say git diff staged. And then you get just that, nothing more. If you want to see what's in your working directory, you say just git diff. And then you get just a comment. Okay? So this is a very useful way to make the changes and then at commit time say split them up so that they make sense. You're taking care of the history after you are done with your work. So now let's commit the first one. Let's call it cd, and now this should refresh. Yes. And now let's add everything, and let's commit cde. All right. How much time do I have left? A few minutes. All right. Let me show you quickly a few more things. Let's say that these two commits that we made right now, we made them on master, but these are part of an experiment. You know, we can realize it afterwards that these latest commits are not meant to be on master. They're meant to be on another branch. Now, if this was another source control system, sorry, you should have thought about it before. But with Git, you can always, you know, change your mind. So let's create a new branch and let's call it experiment. Experiment. And look what happens now. Created a new branch. Just a new reference. Magical. Then, this master branch, how about we don't want these two commits to be in master, so what do? We rewrite this reference so that instead of pointing to E, it points to what it did before, to C. So for that, we use the controversial reset command. Now the reset command moves your current branch, the one head is referencing, to a destination commit. And along with moving the branch, well, it actually moves head, the head reference. It can also synchronize the index so that it matches the commit you want to move to. And optionally, even your working directory, your files, get synchronized to match the snapshot that you're going to. Now, these three modes, either you just move head, or you move head and synchronize the index, or you move head, synchronize the index and the working directory, are the three modes of reset. And what do you think they are called? So to just move head, you would say soft. Soft. Then you just move head, and the index and the working copy are untouched. So that means they still look like the commit you were before. So they will appear as changes. Now, if you want to move head and synchronize everything, then which one will you want to use? Hard? Yes, that one makes sense, now that you know about soft. What about the one where you just want to move head and the index, but not modify your working files? Because you knew it. Okay, it's mixed. Because obviously between soft and hard there is mixed. And this is the default one. So if you don't say anything, it's gonna be mixed. In this case, we want to modify everything, so we say hard, and then we say, where do you want to go? Well, I want to go to C. I could either use the commit hash, or I can use the relative, the syntax to specify a commit relative to another one. And remember, you can only go backwards, as I said before. So you say from head, how many commit backwards following the parents do you want to go? Well, 1, 2. So you can say tilde2. Or, if you feel fancy, you can do hat. This is the same thing. So hat, this means the parent of. So you see how Git starts to look like a programming language. So for a few ones, you can just say like this. Or once you reach more than 3, it's easier to say tilde3, for example. So let's say hat, and then we go like this. Boom. See? Now master points to C, and these are blue because they are reachable from master. However, you see these are gray because they are not, well, they're reachable from head, from my working directory. But these are not. So if I go to check out experiment, then everything is reachable. Okay. I have a few minutes. I want to show you something really, well, let's see if you're willing to stay a few more minutes. I can show you both things. All right? Okay, so let's make another change. Now we want to be in master. I actually have an alias for checkout. I don't like to write checkout every time. So I say CO master. You can make how many aliases you want. And now I want to make a new modification to the file. For example, let's remove this line. Now I removed that line over there because it's unnecessary. So, and then let's commit. Commit all means just commit, stage everything, all modified files that I have, just stage them and commit them at the same time, instead of doing the add and the commit afterwards. So you say commit all, message, CDEF. Great. I get so screwed up. So, I don't know why it doesn't follow the, there you go. So now we are in an interesting situation where you have one commit that is in one branch and another commit and two commits that are in the other. Well, one question you want to answer often is what commits are in what branch? What do I have that is not in master, for example? Now Git for that has a very interesting syntax, which is called the ... or two ... or double dot syntax. Of course you use LG because you want to list them, and then you say or log git show me the commits that are not reachable from master. So you write master ... but that are reachable from that second reference. So you say experiment. Okay? So this means show me the commits that are reachable from experiment, second reference, but not reachable from the first one. So first one is always the not. And then you get E and D. Now what happens if I switch place? Not from experiment, but from master. And I get F. So this is a very useful way of seeing what is where without actually, I was in master all the time. I didn't have to check out that other branch. However, since if you were to say head, if you were to omit one reference, it will imply head. So then it becomes really useful because I can go to a branch, like I do checkout experiment, which is usually the branch where you do work on, and I can say LG whatever, show me what's not reachable from master but it is reachable from my head, from my current branch head. And since that command is generic, I can make an alias for it. So I can say git new. Okay? So I make an alias to see, show me whatever I have in my current branch which is not merged into master. Git new. Okay? And you can, compose this in a way that makes sense to your workflow. So now for the, let's see, let's get rid of, let's make a merge. Well, actually, you know what? Let's make a rebase. How many of you are afraid of rebase? That's okay. I'm also afraid of rebase sometimes. Yeah, a few of you. Now, rebase is this very interesting concept which doesn't seem to belong anywhere. But if you think about it, it's very obvious. So remember a commit as a reference to a parent. So in this case, if you want to merge the changes from experiment into master, you could either make a merge commit, which is a special kind of commit with multiple parents, right? But having a merge commit sometimes makes it hard to see. Once you have a lot of merge commits and multiple branches merged into each other, it becomes hard to see what is coming from where graphically. It creates the so-called Guitar Hero history with a lot of vertical lines, and they merge sometimes like that. So instead of doing a merge commit, sometimes you basically want to make it look like everything happened in one sequence. So in this case, you will want to take D and E and change the parent of D from C to F, right? You will want to, instead of having to do a merge commit between these two, you want to move them so that D gets applied on top of whatever is in master. So that history looks like this. So even if D and E happened before F, we did F afterwards. By changing the parent of D from C to F, it will look like they are all on the same line. And that's what the rebase command does. So we are in experiment. So we say git rebase. Where do you want to rebase on top of? On top of what? I want to rebase it on top of F, that is master. Okay? Now let's see if the trick works. Let me align this perfectly. Yes. So now look at the graph. No, it didn't work. It would have been nice if it didn't move anything. But now you see that everything is in one line. Okay? Now if we get back to master, if I now want to merge experiment into master, something very interesting will happen. Because Git will see that what I want to merge, that is experiment, is already a descendant. So the line of history is not forked, but it's rather already a single line. So we don't need to create a merge commit that ties it all together. Instead, we can do a so-called fast forward commit, a fast forward merge. You see what Git did? It basically said move the master forward so that it points to the same commit as experiment. Okay? Now that we have this, the final thing I want to show you, which might be far off from everything else, but it might be useful to know. It also makes it for a good demo. Now, let's say that we have a bug somewhere. Actually, let me compile this. Now, this is just corresponding to make, or what do you use in Java? Wait, don't tell me. Ant. Gradient, yeah. Gradient? Gradle, thanks. But before that, there was something else. Maven, thanks. That's what I was thinking about. Nobody uses Maven anymore? It's out? I see faces like, no. All right, okay, sorry. In Microsoft land, we are much worse equipped. So we just have whatever the mothership gives us, which is MS build. So we run this and we have an error. So that means that this doesn't even compile, which is kind of embarrassing. But somewhere along these commits, there is a commit that introduces an error. However, we don't know where. And this could happen to you, you know, a range of commits, there is an error somewhere, how do you know where it is? All right. Turns out Git has one of the few commands that actually makes sense, is the one that you can use to debug your code. So what we want to know is which of these commits introduced the error, so we can fix it. And most importantly, we want to know who did it, which is the whole reason why we are doing this. So there is a command called git bisect, and bisect does this. You give it, you say git bisect start, and then you give it two references. You tell Git, okay, give me the range of commits where you suspect there is the problem exists. So in this case, you need to give it where things are bad, that is right now, and where things were last known to be good. In this case, I don't know, so I'm gonna say A. So it's the entire range. So the first reference is where are things bad? Things are bad right now. So we say head. Where were they good the last time? Well, let's say head 1, 2, 3, 4, 5. So head till the 5. Bam. Okay, so what Git does now, you can see, it finds the middle. Yeah, the graph is so screwed up, but doesn't matter. It finds the middle in this range, which is C, and then it stops. It moves head to that one, so your working copy now has this snapshot from this and tells you, okay, try now, does it work or not? And then you say good or bad, and if you say bad, that means that the problem must be earlier than that. So then it finds the middle of the first part, so it does a binary search. But you are trying to find a bug, so you are dissecting. So you are dissecting with a binary search. You are bisecting. Okay? So you could do it manually, run the script at every step, or since you have a script, you can let Git do it by saying git bisect run, and then you give it the script that you want to run at each step. Git is going to look at the exit code from that script, and if it's 0, it means this is good, and if it's other than 0, it means that it's bad, and it moves in the right direction. So we say this, and then we can grab a coffee, and you see it runs a few times, and then it stops. It stops, and it says, let's see, where is it? Where is it? I really want to show you this message. Maybe this. Well, bisecting 0 revisions left after this step. Let's see, I can show you. Maybe one more. No. Well, trust me that it said, there you go. Haha, finally. This one is the first bad commit. There is B. So it says that this is the first bad commit. Let's take a look if it really is the first bad commit by saying, show me what is in head. That is, we are on B right now. And, there you go. There is no readln. Okay? This is the commit that added the line that caused the whole problem. Okay? Now these were like 4 commits, but imagine 20. Now somewhere along there, you can just say run and go get a coffee, and when you come back, there it was. And hopefully it wasn't you. Okay, let me just close this off with 3 concrete tips for getting up to speed or increase your leveling and how you use Git to your advantage. So the first one is learn gradually. So that means Git, as I showed you, has this enormous domain-specific language that keeps growing with new feature. You don't have to learn everything at once. What I will do, what I did, and I'm still doing, is that every time I say, I wish there was a way to do this, there are likely at least 4 ways to do it. Then I Google it, and I choose one that makes the most sense to me, and I just remember that, and then I keep using it. And until the next time I say, I wish I could do this, and then I repeat this process. So with time, you build up this information bank of how to do stuff. And then you will, after 8 years of Git, you will still discover new ways of doing stuff that you thought you already knew all of the ways, but there is always a +1. So, second advice is, do not ask what you can do for Git. Ask what Git can do for you. So instead of trying to memorize all the things you can do, decide how you want to work. So decide your preferred workflow, and then adapt Git so that it serves you in your workflow. Because Git doesn't have any opinion. As I showed you, you can use it any way you like. And the third one is keep a clean history. Because with Git, you have a really good shot at doing it, and your future self and your team will be thankful. Now, there is a lot more I could show you about Git, but we will be here until tomorrow morning. So, if you want to see more, there are lots of resources out there. I don't know if you guys are using Pluralsight to watch courses, for example. Well, if you're doing it, I have a Pluralsight course out. So this is the part where I make some small commercial. And called Advanced Git Tips and Tricks, which you can find at that URL. Don't pay too much attention about the advanced. It's not really advanced. Well, it is, but they really made me add this advanced. I start with the same discussion that I did before in this demo, how Git works internally, and then I build up with, in the end there are some advanced things that you can use, but you get there gradually. And the link is over here, I don't know if you can read it. And with that, we are way over time, I'm sorry, but I appreciate that you stayed, so thank you.